Hello everybody, my name is Itesm. I come from Central Mexico. I am representing Itesm, that is my current school. Today I really wanted to take a different approach to this project, and I think it will be a bit pleasing to know that I didn't just consider what we were going to do once we were there. I actually tried to see like a different perspective of how we are actually going to get there. And that for me is a bigger enough issue, or prioritized a little bit in a higher place than what to do once we're there. Okay, we'll go ahead. And I chose power systems just in case you were wondering. That's my topic. Okay, the outline for today is going to be why power, what I'm going to try to focus on, pieces of the puzzle, because at the end I'm going to try to piece little ideas together into a big idea. Then we get a picture which comes after the pieces, and a quote I used. If I didn't make it, I used it. If it ain't broke, don't fix it. And how it all comes together. Okay. Why power? Well, I believe it is necessary prior to any planning of any mission. NASA, scientists, and the government page states that before you even start planning a mission, before you can even think about going somewhere, you have to think about the power you're going to use, about the energy, and where you're going to get it from, right? Okay. The current energy and power systems we have are important because those power systems, those sources, keep and send our man-made objects into space and outer space. The evaluation of better technology and the discovery of better power systems and energy systems allow us and open doors to future outer space exploration. Focus. Why I focused on this, and I am focusing only on the travel on the trip from Earth to Mars currently. It's not less important. They're both as important. They're just related. The pieces of the puzzle. This part of the presentation is going to try to present the different kind of power systems that I think are more suitable and are more feasible to be able to group into a bigger concept. Well, solar sails. This is kind of a new technology. It's been in development for a while. I think it's got a lot of potential, and I'm not alone. NASA scientists and the Japan Space Agency are already using it. For the U.S. counterpart, they used it in a project called NanoSail D, with the help of a private company and NASA's very own scientists. They sent a mini satellite into orbit using solar sails, and are trying to see if they can control it in the future, if they can control its altitude and its navigation, and how it could also be used for interstellar and deep space exploration. The Icarus project of Japan is already taking place. It was officially finished in 2010. But the spacecraft, which looks similar like this, was originally made to travel to Venus, and it currently is. It kept going. It passed Venus. These sails are specifically designed to intercept the radiation pressure from the sun, photons. And photons, as I said, it's a specifically engineered sail. Photons push it like wind pushes sail here on Earth. Thrust. It has been said and observed, it's just like a hypothesis, that these solar sails could reach 20% of the speed of light. So that would be a pretty big thrust, and you wouldn't even have to burn that much fuel, or even burn fuel at all. Less exposure. A lot faster velocities mean less exposure to the astronauts, and that is one of NASA's biggest interests: how to keep the bones of the astronauts from losing density, and how to keep them away from a long time of exposure of radiation. RPS systems. Now these systems are nothing new. They've been around for more than 50 years. They've been used since Apollo. The current Voyager spacecraft is still using them. RPS stands for radioisotopic power systems. The main two models I'm going to be talking about are the multi-mission radioisotopic thermoelectric generators, or MMRTG, and the ASRGs, which is our advanced Stirling radioisotopic generators. Both are a little different. I'll be explaining them a little bit on. NASA, again, on their website of this RPS systems, has said, that nuclear-based power systems such as the RPSs are critical in space exploration. They run non-explosive and low-risk plutonium-238. This is a kind of plutonium that decays and produces heat. It is stable and it is modular. Modular means that you can take an RPS and you can put 1, 2, 3, 4, as many as you need and you want to take, and you can take. And they can create they can create a group and create the energy together. So it can allow you to take whatever quantity of generators you need to provide the amount of energy you need. Fuel cells, these have also been around, and my peers have talked about these. These, I think, are very efficient and very self-sustainable, and here's why. The main focus of a first mission, we had to talk about this earlier, you have to have a reference mission, right? It's the analog missions, I'm recalling. Now, the first mission to Mars, we've only sent robots, so we really don't know how it is out there. When when the lunar race started, our first ship, which was Apollo 1, didn't have the complex systems that the last Apollo mission had. Because you have to start with simple, and then after you have like some knowledge of what you're actually going after, you have to make the systems better. You can't start the other way around, right? So we use the stuff we have. Why? To make it sustainable. These fuel cells use hydrogen and oxygen to create energy. As a byproduct, they create heat and water. Why is heat important? Well, in the vastness of space, the temperature is very low. So the heat product from these cells can keep the spacecraft systems cozy. And the water can help us feed our astronauts, and they use for water, they can use it to cook and they can use it to drink. The bigger picture, how all these concepts come together, the three main I talked about. Again, if it ain't broke, don't fix it. It's not an excuse to be lazy. It is not an excuse to be lazy. We have the power, we have the ingenuity to create new stuff, but why try to waste time experiment with new technologies? We have perfectly working ones that can help us get there. It is in the short range, not in the long range. How it all goes together? Okay. With the stuff we have, we can adapt it and modify it to feed or to be capable to feed our demands. So we can the vehicles we have, the technology we have, we can make little changes to it to make it work for us. We have to work efficiently, and as I said before, we have to take advantage of what we have and be sustainable. This will allow us to cut costs, focus the money in development of future technologies, and let us focus on what's important currently. For the trip to Mars, I considered 2 stages because you can't fit everything on one stage. The first stage. Okay, what will be needed? Remember we talked about how energy is so important for any space mission, right? So you have this first trip. You are planning a mission on this first trip. Now, energy is quite important for the astronauts that are going to go there. And at the same time, you can't fit everything that they're going to need in one single rocket. So the plan is to send 2 rockets, and here's why. The first rocket would take the habitat of the colonization module, the equipment you might need, and it will generate power. If you put RPS systems, fuel cells, and solar arrays, which are optional, you can generate or you can charge the batteries of the colonization module, and it can launch before the astronauts launch. So that way, in the way there, which would be approximately 6 months, the batteries could be charging, water could be generated from the fuel cells, and you will start like getting stuff together. The second stage would take the humans and like the equipment necessary to get them onto the Mars surface. By the time they get there, the first stage would have already landed. And they've already landed. When they are there, they can just unpack what arrived first. They can take out the batteries that were charged in the way. They can cover a time frame where it will allow them to set up their initial setup, and for a future, like it will give them a time frame where they can have energy, and they will start looking for ways to generate more energy and not run on batteries. Wrapping up. Sorry, before that, as I said, I mentioned that I would focus only on the trip there, but I was also investigating, because you can't really leave it like that. I was also investigating. The MIT did an investigation about the pros and cons of nuclear energy versus solar energy once on the surface of the planet. Now, nuclear energy is very good. It is very stable, and it creates it creates constant electricity. And what we think is that because of the dust storms and the dust devils, the solar panels won't last much. That could be avoided. There's a specific place in Mars, north of the equator, 25 degrees north of the equator, where if you put 100 meter by 100 meter solar panels, you can generate 100 kilowatts of electricity. And that is good because the dirt devils and the dust devils stay beneath the equator mostly, so you can avoid them quite easily. Now, the solar panels don't have to be rigid. There's some solar panels that can be rolled up as a mat, so you can transport them and then just find a way to put them, stick them to the ground, and they can be constantly generating the power you need. I'd like to end this presentation with 3 main points. We have to be efficient in the use of existing technologies. If it ain't broke, don't fix it. You don't need to make new systems if you have working ones, right? And as I said, the combination of these systems will allow us to decrease the harmful radiation exposure and bone loss for astronauts. Questions? Out like tanks of what you're going to need, and once in Mars, when the batteries are charged, you can find hydrogen almost anywhere in the universe. The thing is, how do you convert it to liquid hydrogen? And that is a different complex procedure I did not investigate. I'm not going to try to lie my way through it.
But that was a good answer.